So please do write it. I'm going to write some point about this. Carboxylic acid, then I will explain the reaction. Carboxylic acids react with ammonia. React with ammonia to give ammonium salt. To give ammonium salt, which on further heating, please do write with me. Please do let me know when you are done with this.
Yes, sir, done.
Very good. So see how the reaction took place. Yeah. See how the reaction will take place. So it's very easy to understand. If you are going to react this carboxylic acid with ammonia, the final product will be basically your amide. And this reaction will be used as preparation of amide in the next chapter, which is amine. So see, you know that this CH3, COOH is an acid. So it will be converted into O minus, and this is your converted into H plus. Then NH3, as you know that this NH3 is a base and which has a lone pair, so it can make a bond with this H plus coordinate bond and it will become NH4 positive. You have seen this compound in chemical bonding. So what nitrogen will do, it will give one electron to hydrogen and make a covalent bond with that hydrogen, which bond the bond which is formed is called coordinate bond. And since nitrogen gave the electron to hydrogen, so it has positive charge, and this is your CH3 COO minus. Now the bond between O minus and N plus is basically ionic bond, force of attraction between them, and this is known as your ammonium cyanide. After forming this ammonium acetate, not cyanide, sorry, after forming this ammonium acetate, you are going to heat it, and when you are going to heat it, what happened here, there will be elimination of H2O. There will be elimination of H2O. So in what way H2O will go? So you can see this is your NH4 positive. So this is your NH4 positive. NH4 positive, and there is CH3 COO. CH3 C double bond O. O minus is here. So what will happen here? This O and two hydrogen will be eliminated, and there will be bond between these two. There will be bond between these two. So what we have left, CH3 C double bond O, and you can see NHH. Positive will be eliminated because nitrogen will give its electron. So in this way, this forms. Is that clear, everyone?
Yes, sir.
Okay, Anushka, yeah, Ahmad, I need to talk to you. I checked your paper, the mock test, and I already told you when we were in self-study group that please write clear, and also when you are making a PDF of that, please make sure you are going to read it before signing it, because Uh, the PDF is not so clear. Are you getting my point, Ahmad?
Yes, sir. Okay.
So please make sure you are going to at least write clearly that I can understand easily.
Okay, sir.
Okay. And
Okay.
I think you haven't prepared well. That's why you didn't get that much good marks. But I also uh, checked the paper strictly. Okay.
Okay.
Okay. Thank you.
So
So
how much I got, sir?
you got, you'll know. I didn't count it, but you didn't get that good marks. It was
Sir,
important.
have you checked my paper?
No, I was checking before that this class. I wasn't able to check your. Now you'll get to know in the next class. I'll tell you definitely.
Yes, sir.
So please, everyone done with this? Can I change the slide?
Yes, sir.
Okay. Please do write the final product along with the ammonium benzoate or whatever it is. First, you are going to write the A product and you are going to heat it, and there will be elimination of H2O. Then B. Let me know when you are done with this. Are you done with this?
Yes, sir.
So what you got here, you will get sodium benzoate. So not sodium, it will be ammonium. This was like this. So it will convert into C minus. H plus will be eliminated and there is NH3. So it will take hydrogen and it will be like this. And if you are going to heat it and there will be elimination of H2. So you can see one of the oxygen and this two hydrogen will be eliminated and it will form amide, benzene amide, and it will be basically CONH2, CONH2. So you can do this easily, CONH2. And its name will be benzene, benzamide you can write. Is this correct?
Yes, sir.
Very good.
Sir, I only got the B part wrong. A, I got it correct.
Okay, okay. You got it wrong, the B part?
Yes, sir.
Okay. Please do that. Alan, what about you? And Ahmad?
Yes, I got it.
So I got this one.
Okay.
Sir, is that CONH2 or 3?
This is CONH2. At the last
Yes.
you are asking CONH2.
Yes, sir.
Wait a minute. Yes, everyone done with this? So I'm going to give you some question. So this is very easy and important question. And the question is, which acid shown here would you expect to be strong? Would you expect to be strong? The first you can see is CH3CO2H, or the second one is CH2F CO2H. The second from second, this is your CH2F and CO2H, or here it is CH2Cl, and this is your CO2H. And in third, you are going to tell me about this CH2F and CH2 and CH2 and CH2 or CO2H, or you can write CH3CHF CH2 CO2H. This is your COOH and this is your CH. In each of the following, you need to tell me which one is more acidic and which one is less acidic. Please do tell me. I'm ready.
So in the first one will be CH2FCO2H.
For the first one, which one is more acidic? CO2H or CH2F?
Sir, CH2FCO2H.
There you go. This one is more acidic. What about you, Ahmad?
Sir, CI answer. CH2.
CH2. Are you talking about this?
Yes, that this
It
CH.
will be more acidic because you can see this fluorine most electronegative, as you know that in the previous class I had discussed about acidity, directly proportional to electron withdrawing group. Yes or no? So this one is right answer. What about this? What about the second one, Alan?
The same is CH2FCO2H.
Very good. CH2FCO2H, because fluorine is more uh, electronegative than chlorine. That's why. What about the third one?
CH2 FC.
I think it'll be second option because of stability of resonance.
Yeah,
Yes, sir.
you
It will be the
can
second.
see if fluorine is nearby CO2H, that's why. Because this inductive effect is inversely proportional to distance. If distance increases, inductive effect power decreases. Are you getting my point, Emma?
Yes, sir. Yes.
Okay, what about the fourth one?
This one also I didn't have an idea.
You
So is
don't
it the
have any.
first one?
Yeah, this is CF3. So since you can see, this is the electron withdrawing group 3 and there is no electron withdrawing group. This CH3 has plus I effect. So this will be the more acidic.
Yes.
Okay, everyone. Alan, you also have done the fourth one, right? Fourth one.
So I couldn't hear you properly.
I was asking, have you done the fourth part?
Yes, sir.
Okay. Now the next reaction for this basically carboxylic acid with ammonia. If you have dicarboxylic acid in this way, you can see this is your benzene in which COOH is here and in which COOH is here, and you are going to react this with NH3, that means ammonia. Then what will happen? Here you are going to make it, this NH3 will be in excess. So that's why there will be formation of COO minus and NH4 positive, and then again COO minus and NH4 positive. And as you can see, you are going to eliminate water. So there will be two elimination of two molecule of water because we have two group here. That's why. And then you can see this will be the product. You will C double bond O and then C double bond O, and then there will be NH. And this is a very famous compound that is known as phthalimide, in which pH is silent. So this is your phthalimide. Okay. Now wait a minute. First of all, this will be converted into. There are two ways to do. This will be converted into this. Please do right up to this, and you can convert into this into directly into amide in this way. Now wait a minute. I just wait a minute. First, I just skipped now what we say stay. So if you are going to react this COONH2, this is phthalimide. Okay. Okay, this is also, if you are going to react this with okay 2H2O, so it will form basically this, and there will be formation of CONH2. This your NH, please make sure you are writing it correctly. CONH2, NH2. And after this, you are going to use reducing this NH3 using a strong heating. If you are going to heat strongly, then this compound will form, which is known as phthalimide. Please do write. And this is basically your phthalimide, and this compound is basically your phthalimide. Phthalimide. The difference you can see. This is your phthalimide, and this is your phthalimide. Okay. Let me know when everyone done with this.
Sultan.
Are you done with this? Very good, Anushka. Ahmad, are you done with this?
Yes.
Okay. So now we are going to study the next type of chemical reaction, reactions involving COOH group. And in this, we are going to talk about this reduction. So in reduction, you know that if you're going to oxidize alcohol with mild oxidizing agent, it will be converted into aldehyde, and then again you are going to use this mild oxidizing agent, it will be converted into carboxylic acid. But if you are going to use a very strong oxidizing agent in alcohol, primary alcohol, it will be directly converted into carboxylic acid. So if you are going to use a very strong reducing agent, then carboxylic acid is directly converted into alcohol. So I'm going to write this is your carboxylic acid, and if you are going to use this lithium aluminum hydride, LiAlH4, the presence of ether, and in this side you are going to do hydrolysis in the presence of acid H3O positive, or at the place of LiAlH4 lithium aluminum hydride, you can also use B2H6 diborane. Then it will be directly converted into this RCH2OH alcohol, in the way that we oxidize alcohol into carboxylic acid. So if I'm going to CH3, CH2, CH2, COOH, and using these reagents, can you tell me the name of the product? Please. Everyone done with this?
Yes.
Okay. So what is the name of the product? Anushka, Ahmad, and Alan.
Sir, I had a doubt in this, so could you just explain?
See, if you know how to oxidize alcohol into carboxylic acid, you know that propanol will be oxidized into propanoic acid. So this propanoic acid can be reduced to propanol. So this is your butanoic acid. So it will be directly converted into butanol. Is that clear?
Yes, sir.
Very good. Please do write it. Everyone done with this? Anushka, are you done with this? So this is about reduction. I'm going to change the slide.
Sir, 1 minute, I'm still writing.
Okay, please do write it and let me know. Done.
Yes, sir.
Now write the topic this decarboxylase. So you have studied this reaction in class 11th also. Decarboxylation, that means you are going to remove CO2 or carboxylic acid, removal of this carboxylic acid type. So I'm going to write a point. This carboxylic acid lose carbon dioxide to form hydrocarbons on treatment with sodium hydroxide and calcium oxide and heat. It will be directly converted into hydrocarbons and there will be loss of carbon dioxide which will react with sodium to convert itself into Na2CO3. So as you can see, carboxylic acid, first of all, you need to take care of this. Wait a minute. Carbon dioxide to form carbon. Wait a minute. Let me write in a better way. Not directly. So this you can see carboxylic acid lose carbon dioxide to form hydrocarbons when their sodium salts are heated with soda lime. What is soda lime? Soda lime is NaOH and CaO, mixture of NaOH, sodium hydroxide and calcium oxide in the ratio of 3:1. And this reaction, you know that this is decarboxylation. This reaction is known as decarboxylation. This reaction is known as decarboxylation. Now, as you can see, if this is your carboxylic acid, and if you are going to replace this hydrogen with RC-OONA, replace this hydrogen with RCONA. So this is your carboxylic acid salt or sodium salt of carboxylic acid. Sodium salt of carboxylic acid. Now what you need to do, you are going to use this sodium salt of carboxylic acid and react this with soda lime, that means NaOH, and calcium oxide and heat it. When you are going to do, it will be converted. This whole part will be eliminated or broken. This part will be broken, and you can see this will be COO-Na2, Na, and Na will take this, so it will form Na2 and then CO3, sodium carbonate, and there will be formation of hydrocarbon. So please do write it and let me know. Let me know when you are done with this. Alan, Ahmad, Anushka.
Yes, I'm
Sir,
done.
almost done.
Okay, almost done. Then that means I can give you a question. I'm gonna write a question here. Right. This is your basically main product is this. Ahmad, what about you? And what is the name of the main product? What is the IUPAC name of the main product? We have studied
So it'll be
all this
ethane.
class.
So
What
it'll
you
be
just said?
ethane. So it'll be ethane.
Ethane. Very good.
Yes.
Very good. Are you done with this, Anushka? So you can see this will be eliminated and there will be formation of CH3, CH2 was there, and hydrogen will be added, so it becomes ethane. And the byproduct will be Na2CO3. Right, Ahmad?
Yes.
Anushka, can I change the slide?
Yes, sir.
Now come to the next reaction, which is substitution reaction by the hydrocarbon part. Substitution. Substitution reaction in hydrocarbon part. In hydrocarbon part, and the first reaction is basically halogenous. Halogens. So as you can see, halogenation, that means you are going to add halogen and there will be removal of something where halogen will be added. That's why it is substitution. And this is a name reaction which is very important, and its name is Hall-Volhard-Jelinsky reaction. So I'm going to write a point about this. Write with me. Carboxylic acids having an alpha hydrogen. Carboxylic acid having an alpha hydrogen are halogenated at alpha position. Halogenated at alpha position on treatment with chlorine or bromine. On treatment with chlorine or bromine in the presence of a small amount of red phosphorus, in the presence of a small amount of the red phosphorus, to give alpha halocarboxylic acids. And this reaction is known as basically this reaction is known as Hall-Volhard-Jelinsky reaction. Please do write it, and then I'll show you the reaction.
Sir, done.
Very good. Everyone done with this?
Yes, sir.
Very good. Now you can see you are already aware of this alpha beta. So if you are going to react this carboxylic acid, you can see this is RCH2 and this is your C double OH. First, you are going to react this. In the first step, you are going to react this with X2, that means halogen, in the presence of red phosphorus. And in the second step, you are going to do hydrolysis. So what will happen? As you know that this is your alpha carbon, because this is your functional group, that means this is your alpha carbon. So it will be RCH. There will be substitution of substitution will take place, and H will take the place of alpha hydrogen, and this will be C double OH. And this X is only for chlorine bromine, not for iodine and fluorine. Iodine is very large and fluorine is very small and very high uh, electronegativity, and this is known as alpha halo carboxyl. So it's very easy reaction. As you can see that only you need to replace this H with X. So if I'm going to give you a question like this, can you tell me the product? Please do let me know the name of the product.
So that'll be 1-chloropropanoic acid.
Can you repeat it again?
So 1-chloropropanoic acid.
Is it propanoic? Will it be propanoic? And how can it be 1-chloro?
So it's like any halogen and then there's 5 carbons, right? So propanoic acid.
Propanoic acid. It is pentanoic acid, no? Prop used for 3 carbon.
Sorry, so I mean pentanoic acid, right here.
Yeah.
And then the
So
halogen can be, yes, so it'll
you
be,
can see. So yeah, this is your functional group. So it will be your alpha carbon, and there is 2 alpha hydrogen. You just need to replace one of the alpha hydrogen with chlorine, and the rest part will be as it is. So if you are going to name in terms of number 1, 2, 3, 4, 5, so the name will be 2-chloro
2-chloropentanoic
pentanoic
acid.
Pantenoic acid. And if you want to do in terms of alpha, beta, gamma, so as you can see, this is your alpha at alpha carbon, so it will be alpha chloro carboxylic acid, you can write, or alpha chloro pentanoic acid. Anushka, did you get it?
Sir, I made the same mistake as well.
Oh, okay. Please do let me know when you are done with this.
Yes, sir.
Very good. Now the next question is basically ring substitution. So as you can see, ring substitution, as you can see, basically there are some groups which are meta activating. So I'm going to write a point. Please do write with me. Aromatic carboxylic acid undergo electrophilic substitution reactions in which carboxyl group acts as deactivating group, acts as deactivating and meta directing group. Meta directing group. Does everyone knows about this deactivating, ring deactivating or ring activating group? Please do let me know if you don't know.
Sir, I don't know about
Let
that.
me finish this. Okay. They do not undergo Friedel-Crafts reaction. Friedel-Crafts reaction because carboxyl group is deactivating and the catalyst aluminum chloride, which is Lewis base, sorry, Lewis acid, aluminum chloride, Lewis acid gets bonded with carboxyl group. So please do write it and then I will explain each and every point. So always remember this ring substitution. If you are going to do the Friedel-Crafts reaction, in which the name reaction you have studied in all this haloalkane haloarenes as well as alcohol. So this Friedel-Crafts reaction do not take place in carboxylic acid because this carboxyl group is basically ring deactivating group, and the catalyst used in Friedel-Crafts reaction, which is AlCl3 or aluminum chloride that becomes AlCl4 positive, is basically Lewis acid and it will get bonded with carboxyl group. So please write up to this and then I will again explain. Are you done with this, everyone?
Yes, sir.
Okay. So, can anyone do the what we call resonating structure of this carboxylic acid? Can you do the electronic resonating structure of this carboxylic acid? Yes or no?
Sir, try.
Okay, please do try, everyone.
Sir,
Yes, are you done
sir,
with this?
no, sir. So I have a doubt in this. Could you
Okay,
explain?
see. Okay, see, this COOH is a ring deactivating, which means minus R effect. It will show. That means it will take electron. Oxygen is more electronegative, so it will withdraw electron from carbon, and there will be bond like this, as you can see. So this is C, and it will be O negative, and there is OH. And since hydrogen donated its electron, so it will have positive. Double bond is added. Now this bond will be broken and move to this place. So there will be double bond, and then C, and then this is O negative, and this is OH, and there will be positive sign, and then double bond, double bond. Again, you can see this will be moved to there, this will move to there, and then again. So as you can see, positive sign will be here, double bond, and this is double bond, C, O negative, and this is OH. Again, if this will move here, so where will be the positive sign you can think of? There will be positive sign, double bond moves to here, and then here, and this. You can move twice in a single step, like you can do this, moving to this place and moving to this place. Delocalization of pi bond or pi electron simultaneously. So this is this, and this was this, and this will move to this. And again, you can see there is delocalization of pi bond. This is the resonating structure of this benzoic acid. Is that clear? So if you are going to see with respect to this group, if you are going to see the positive charge is at ortho, then para, and then again ortho, not at meta position. So, and the first of all is it is ring deactivating group. Since it is taking electrons, so it is ring deactivating group. And we are studying electrophilic substitution reaction. That means electrophile will attack the ring. Electrophile will attack the ring, and electrophile is the one which is deficiency, which have deficiency of electron. And in the ring, you can see there is positive charge here, there is positive charge here, and there is positive charge here. And positive charge represent it is having deficiency of electron. And if someone which is already have deficiency of electron cannot attack at this place and at this place and at this place. Are you getting my point? Because it is already having deficiency of electron, and if someone some group which have deficiency of electron cannot attack because both cannot fulfill their own desires. Are you getting my point? Anushka, Emma, Alan?
Yes, sir.
So that's why in this reaction, if you are going to do the reaction for wait a minute, this is your benzene, or you can call it now benzoic acid. If you are going to react this with concentrated HNO3, concentrated HNO3 plus concentrated H2SO4, concentrated H2SO4. So basically this there is formation of nucleophile which can easily attack on meta position, because at least on meta position there is no positive charge. That means at least at meta position it can attack because it doesn't have any positive charge. It is more electron rich than ortho and para position. So please do write this reaction first, which is also called nitration, and then I will write the bromination, or you can call it halogenation. Let me know when you are done with this.
Sir, done.
Everyone done with this? Ahmad?
Yes, sir.
Okay. Now the next
Yes.
electrophilic substitution reaction, thank you. You can see is basically your this carboxylic acid, C double OH, and Br2, FeBr3. So Br will be directly added at meta position here. So we can write its name M-bromo benzoic acid. Okay, with the test you you all have given, you don't do you send it to Learnivio's WhatsApp? Yes or no?
Sir, the mock one, the mock test.
No, I got the mock one. No, just before the class on Monday. Like in today's class, you have given a test for half an hour, right?
Yes.
Yes, sir.
Okay. Please do send that also so that I can check and see what is the mistake
So I'm not
you
audible,
got
sir.
in it. I'm saying that the test you have given today at 6:30 p.m. Please do send that. Okay.
Sir, actually, I was not able to finish the test completely.
Yeah.
Okay. So from the next time you are going to finish it and send it. Okay.
Yes.
Are you done with this? Everyone?
Yes, sir.
Yes.
Okay. Here are chapters completed. Now I'm going to give you some reaction complete, and you are going to send it to Learnivio's WhatsApp. Complete each synthesis. Please do write with me. Synthesis. Wait a minute. In the next class, we are going to start amine. Everyone writing with me?
Yes, sir.
Very good. Please do let me know when you are done with this. See, everyone, focus here for the instruction. You are going to write the reaction and complete the following. Here you are going to write the product in this 1, 2, 3 and fourth reaction. And in the fifth reaction, you are going to tell me the name of the reagent used for conversion of this reactant into product. Is that clear?
Yes,
Is
sir.
that clear, everyone?
Okay, sir.
So when you are going to finish it, after finishing it, you may leave and send this solution to Learnivio's WhatsApp. Okay? Thank you. Don't
Sir,
leave
when
this
should we send
without
it by
completing
today
this.
or how? Until when
By
can we send?
just after class, just after class. Okay? Thank you.
Yes, sir. So I've written this. May I leave?
What you just said, Anushka?
Sir, I'm done writing the question. Can I leave?
No, just don't leave. Just complete this solution and send it to me. You may leave after just completing this with answer.
Yes. Yes.
Okay. Can everyone see the screen?
No, sir.
Yes, sir. It's visible.
Now it's
You
visible.
can see the screen? Okay.
Yes, sir.
Okay. Thank you. After seeing, okay.
Sir, could you repeat?
After finishing, you can leave.
Yes, sir.
So I sent a paper.